Welcome to another statistics warm-up. So let's see what we've got here. Norma has 15 cats. Ethel has 8. Edith has 21. How many cats does Doris have if the average number of cats for the 4 crazy cat ladies is 12? All right, so this is actually like an old algebra style problem, but we know that to calculate an average, we have to add up all of our values. So I'm going to do that. 15 plus 8 plus 21 plus x, because we don't know Doris. We have to divide by our sample size, which is 4. And if we do that, we're going to calculate the average, which the problem tells us is 12. So then we just have a little equation we can solve here. We can multiply both sides by 4 and get 48. We can combine our like terms here and get 44. And then we can solve that pretty easily and say that x equals 4. All right, so Doris has 4 cats. All right, so let's take a look at the next one. It's going to be difficult, but imagine a random stats class that contains 9 girls and 8 boys. If the mean for the girls is 7 hours of work and the mean for the boys or males is 5 hours of work, what is the overall mean for the class as a whole? So if we were to combine the 9 girls and the 8 boys, what would the new mean for the class be? All right, now, first of all, we can't just combine these. We can't just say, oh, the mean of 7 and 5 is 6, so the class mean would be 6, because the numbers aren't balanced. We have a different number of girls than we have boys. So there's 2 different ways that you can kind of think about this. One is we can say, all right, well, if there's 9 girls and they average out to be 7, we can basically think of that as having 1, 2, 3, 4, 5, 6, 7, 8, 9. We can basically think of that as having 9 sevens. All right. Now, granted, all 9 girls probably didn't have exactly 7 hours of work, but if they averaged out to 7 hours of work, it doesn't really matter. We can just think of it that way. And we can do the same thing for the boys. We could say, all right, there were 8 boys. So let me add all of these. 1, 2, 3, 4, 5, 6, 7, 8. And then I could take the average of those values. So I have 9 sevens, so that's going to be 63. And then I have 8 fives, so that's another 40. So if I were to add these all up, I would get 103 over 17. All right, and then I would just type that in. It's 103 divided by 17 and get something like 6 point, we'll say 06. We'll go to the nearest hundredth on that. All right, so that is one way you can do it. The other way you can do it is something basically called a weighted average, which is where you're saying, all right, the average for the girls was 7, but the girls only represented 9 out of a total of 17. All right, plus 5. But again, the boys only represented an average of 17. Now, what you're going to see is that thinking about it this way or thinking about it this way is pretty much the same thing, all right? When I multiply these, I'm going to do 7 times 9 and get 63. I'm going to do 5 times 8 and get 40. So I'm going to have 63 over 17 plus 40 over 17, all right? They have the same denominator, so I'm going to combine them. I'm going to end up with 103 over 17, which is exactly what I got there, which is going to give me the same exact answer. So whichever way is easier for you to think about is fine. You can either think of it as like 9 sevens and 8 fives, or you can do this sort of weighted average model. They give you the same exact answer. All right, number 3, listed below are weights on the defensive linemen of a professional football team. Would any of these values be considered an outlier? Justify your answer. All right. So last class, we learned that to be considered an outlier, you have to either be 1.5 times the IQR below quartile 1, which is why we're subtracting, or you have to be 1.5 times the IQR above quartile 3, which is why we're adding there. All right, so below quartile 1 or above quartile 3. Now, again, the interquartile range is Q3 minus Q1. And we can find that either by putting these numbers into our calculator, into L1, and then running one variable stats, or this is quick enough that we can say, all right, we've got 7 people, so 306 is my median. And then I find the middle of everything to the right, and I find the middle of everything to the left. So that means that 303 is going to be my Q1, and 315 is going to be my Q3. So when I'm figuring out the IQR, I'm just going to do 315 minus 303, which means that my IQR is 12. Remember, the IQR is a single number, just like our range. And then we're going to go over here and we're going to plug in our different values. So Q1 was 303 minus 1.5 times 12. That's going to give us outliers on the low side. And then we're going to do 315 plus 1.5 times 12 to see if we have any outliers on the high side. So the first one works out to be 285. All right, and then on the other side, it should work out to be 333, I think. Let me just double check to make sure I don't write down the wrong answer. 315 plus 1.5 times 12, 333. So the question is, does 285 count as an outlier when it's exactly the same? And we said that it had to be above or below this benchmark. So technically, we have no outliers because nothing is below this value. All right. And then obviously on the other side, we don't have any upper outliers or large outliers because 318 isn't even close to 333. But I said this before, if you're that close to being an outlier, it's a good idea to sort of see what effect that observation is having on your results, because it is right there on the edge of what we consider an outlier. All right, but technically, no outlier because nothing is below this value. So that 285 would not count. Right? Being equal is not enough. All right, according to the Census Bureau, the mean and median of 2008 income of people at least 25 but no higher were 48,097 and 60,954. Which of these numbers do you think is the mean? Which of these numbers do you think is the median? Explain your thinking. All right, so this goes into that discussion of the shape of the distribution. Remember, when something is left skewed and it has a tail off to the left, the mean is less than the median. When something has a tail off to the right, the mean is greater than the median. And when it's symmetric, the mean is equal to the median. All right. So we've got these two numbers here. Obviously, they're not equal. We have to think, okay, we're dealing with income. Which way is this distribution likely to be skewed? All right. If we think that it's right skewed, then the mean would be 60,000 and the median would be 48,000. If we think the distribution is left skewed, then the mean would be the 48,000 and the median would be the 60,000. I would accept different arguments here, but my gut instinct is that 60,954 is the mean and 48,097 is the median. All right. And my thinking there is that you're more likely to have a right skewed distribution when you're talking about something like income, because you could have some young, most likely if it's 2008, young sort of internet millionaires or billionaires that came up with really incredible software that the business world went crazy over and lavished them with all sorts of money. So I think that you're more likely to have a right skewed distribution. And when the distribution is right skewed, the mean is going to be larger than the median. So explain your thinking. The distribution is likely to be right skewed due to we'll just say internet millionaires and similar people. All right. Now, again, a question like this, it really comes down to your explanation. All right. If you give me a convincing explanation for one argument or the other, I would be willing to consider it, but it just has to be a statistically sound and reasonable explanation. All right. And that's kind of a judgment call. But saying the distribution is likely to be right skewed is a good start. If you said the distribution is likely to be left skewed, then I would have expected these to be reversed. And then I would have wanted an explanation on why you thought it was left skewed. But the thing that I'm really concerned about on a question like this is that you're getting this relationship correct. That when it's left skewed, the mean is less than the median. And when it's right skewed, the mean is greater than the median. All right. So let's take a look at the last one here. Last year, a small cactus farm paid each of its 5 entry-level farmers $22,000. Their 2 experienced farmers $50,000, and their farm's owner $270,000. What is the mean salary paid at this farm? What is the median salary? Write a sentence describing how an unethical recruiter could use statistics to mislead prospective employees about the lucrative opportunities in cactus farming. All right, so median. Remember, the numbers have to be listed in order. Now, I'm not going to write out 22,000. I'm just going to abbreviate it as 22. And I have 5 of those. All right. Then I have 2 that are making 50,000. And then I have 1 that is making 270,000. All right. So in total, I have 8 people. All right. So my median is the average of those 2 values, or put another way, the median is just 22,000. Now, when I'm finding the average, yes, I can add them all up, but I mean, just recognize that 5 times 22,000 is the same as adding 5 22,000s plus 2 times 50,000 plus 270,000. And all of that is going to be divided by the 8 different employees. So 5 times 22,000 plus 2 times 50,000 plus 270,000, all right, divided by 8 works out to be a mean of 60,000. All right. So how could they use statistics to mislead? All right. So an honest statistician would use the median because we have a right skewed distribution, which means the mean is being dragged up by this outlier, which is the farm's owner. So a median is a more accurate measurement of the center of the distribution. It's a more accurate measurement of what is typical. The mean, it's not wrong. Technically, the mean is 60,000, but it paints a misleading picture of what is typical of someone working in this field. So the recruiter could use the mean even though the distribution is right skewed. And should be described using the median. All right, so again, it all comes back to just understanding the shape of the distribution and then what numbers or what tools we should use to describe that distribution based on its shape. All right, so that's it for this. Hope this was helpful and have a good day. Bye.